the Introduction to Hypothesis Tests. In this section, we're going to learn about what hypothesis tests are and how they're constructed. We're going to learn about the concept of them, null and alternate hypotheses, and type 1 and type 2 error. In the next subunit, we'll learn to actually do one-tailed and two-tailed tests. So what is a hypothesis test? We want to say something about the world, or as we've been saying, the population. We don't know what the real answer is, but we have a guess. So we gather some evidence and we see if it goes along with our guess, or if it is far enough off that we think it refutes it. We don't know what the real answer is, but we do have a sample to help us guess at what is likely. Conceptually, we've been looking at the standard normal curve, and we've noted that if something conforms to this, we expect most of it to fall in the middle, but things out in the tails are unlikely. With a 1.96 z-score, the likelihood of being out in this tail is 2.5%, and the likelihood of being out here is 2.5%. This center region is where we are confident about the null hypothesis, and we call these tails the critical region, where we're critical of the null hypothesis. So for example, the null could be about the mean, in this case being 0, and the alternate would be that the mean is not 0, i.e. it's so far out here that it's too far away. We call the 1 minus 95% the alpha level, and when we're dividing it into two tails, we take alpha divided by 2, so 0.05 or 5% divided by 2 gives us 2.5 in each tail. So the process is, first we have to decide what we want to be able to make a claim about and what evidence we will have or have. Then we set up our null and alternate hypotheses, figure out the appropriate test, Z or T, one-tailed or two. We're going to be unpacking those for a while. We're going to start with the Z test. Then calculate your test statistic, which is the result based on your sample. Perform the test, and so compare that to a critical statistic or a p-value compared to an alpha value. Again, we're going to do all of this, and then make a conclusion about the null and interpret the meaning of your results back into words that people will understand. So let's talk about null and alternate hypotheses. The null hypothesis is designated HO, and the alternate hypothesis is HA. And we always present the null first and then the alternate, so HO on top and then HA. But it's often easier to write the alternate. It's easier to think about what that should look like and then back into the null. Because the alternate should be about what you would like to say at the end of the day if your test comes out significant. So the thing we're interested in finding out, what we would like to find out about, or what we're worried about. Like if this is happening, then that's bad and we need to know about that. HO is really worthless. It's just kind of a straw dog. It's sitting there to hold the rest of the probability, and it is the complement of HA. And so given that, we know that the probability of HO plus the probability of HA has got to equal what? Yes, it's got to equal 1. So we will do our test, and then based on the results, we're going to do something with the null hypothesis. We're either going to reject it or we're going to fail to reject it. And those are the only two things you can do with the null. If we reject the null, then we have to accept the alternate, because we have to have some idea of what is true and real. And so the alternate becomes that. If we fail to reject the null, then we just leave it sitting there. So these are the only two decisions: reject the null, in which case you can accept the alternate, or fail to reject the null, And so you can probably see that's why we want to put the interesting stuff in the alternate. So if we reject the null, we get to say that. Because we don't, even if we fail to reject the null, that doesn't mean that we've proved it, we can't conclude it, and we don't accept it the way we would accept an alternate. If we reject the null, then we can accept the alternate. If we fail to reject the null, that doesn't mean we accept it. We just kind of provisionally hold it there. Why? That might seem a little funky. And the reason is because of type 1 and type 2 error. So here's a map of type 1 and type 2 error. So here's reality up here. The null is true or the alternate is true, right? One of them has to be true because they're complements and the whole universe is encompassed in these two. So if the null's true and you fail to reject it, you are correct. Yay, that's good. If the alternate is true and you reject HO, which means you also accept HA, then you're also correct. Yay, that's good. Okay. However, if the null is true, but you reject it and accept the alternate, you are wrong. And you've made an error. And the amount of that error is alpha. Okay. If the alternate is true, so you should reject null and accept alternate, but you don't, you fail to reject the null, then you're also wrong. Okay, so this is wrong. And the error level here is beta. Okay, so alpha is a type 1 error, beta is a type 2 error. And type meaning one goes in one direction, one goes the other direction. So usually we focus on the type 1 error and we set that at a certain level. And often, as we've been saying, we want to look at sort of 95% confidence, like our confidence interval. And that means alpha is the complement and it is 5%. So 1 minus alpha is going to be the confidence level. We don't usually measure type 2 error. And in statistics, when we know we're making an error possibly, but we can't tell you how likely that is, that makes us very nervous. So that's why we fail to reject the null instead of accepting the null, is because we don't have the error rate. Now, the problem here is that you can't manage both of these simultaneously. So if you want to decrease your type 1 error, that tends to increase your type 2 error. And if you want to decrease your type 2 error, that would make your type 1 error worse. So since you can't minimize both of these simultaneously, it's like a seesaw, we have elected to focus on type 1 error. Okay, and so what we do is we manage our alpha level, often at 0.05. Next, we're going to learn how to actually apply this.